everybody, welcome back to my channel. ASP.NET Core Web API Part 2. In the previous episode, we have created our first project, and after that, we create our first controller and first endpoint. Now, we have created and we work with the HTTP method, and we know what is all existing HTTP method. But there's one question: how does ASP.NET Core know when a request comes to the API? How does ASP.NET Core knows which controller should choose and which method inside the controller should be executed? For example, when we have a request that it say get API task, how does ASP.NET Core knows? For example, I have two methods, get all and get by ID. How does the ASP.NET Core knows? For example, the get all should be executed. My friends, in this video, we are gonna to know everything about controller, routing, route params, model binding, and everything that's related to that. And one important thing, and you will learn how does the ASP.NET Core knows which controller and which method action should be executed. Let's get started. Okay, so let's get back to our task management project. In the previous episode, we create our first controller here, task controller, and our first endpoint, HttpGet. We had something similar to this, okay? At that point, our main goal was simply to create our first API endpoint and understand how we can expose an HTTP endpoint from our application. It's so important, my friends. But today, we are gonna to look at the same code from a different perspective. It's so important. Instead of asking, how do I create an endpoint, we are going to ask, how does the ASP.NET Core know that this endpoint should be handled in the particular HTTP request? It's so important, and if you know this, you will be one of the senior programmer in ASP.NET Core Web API. And once you understand that, controller and routing will make a lot of more sense. Let's get started. Before we get started, we have to know what is a controller. Here we have a class, that's task controller, and it's so important. In a web API application, my friends, a controller is a class that contains action that can handle HTTP requests. For our task management application, it makes sense to have task controller because our API is working with the task. Okay, the idea is that each controller group related API action together. For example, inside the task controller, we have an action that get all tasks. We also create some action that creates some new tasks, delete all tasks, and update existing tasks. But there is one important question. ASP.NET Core needs to determine whether the method here, the method, how can handle a particular request. Okay, this is where routing become so important. So think about the relationship like this. The controller contains our action. For example, here the task controller can contain this action, okay? And routing help ASP.NET Core to determine which endpoint. This is one of my endpoint, okay? A request belong to, and then ASP.NET Core can execute that appropriate action. For example, for HttpGet, for example, get API task in the previous episode, the ASP.NET Core decide to execute this action, get all tasks. Okay, we are gonna to see exactly how that happened in the API. Let's get started. Now, let's talk about the routing. For example, here in my task controller, suppose our client send a request like this. For example, something like this, get API and task. Routing it's so important. Routing is one of the most important concepts in ASP.NET Core. In very simple terms, routing is the mechanism that helps ASP.NET Core match an incoming HTTP request to an endpoint. For example, imagine that our client send a request like this, API task. ASP.NET Core receive this request, I mean get API request, and it needs to figure it out which endpoint is supposed to handle this request. It's so important. Suppose, for example, I have another endpoint, Shift Alt and something, and we have something else, for example, get all. And how does the ASP.NET Core know which endpoint is supposed to handle this request? That what routing helps. You can think of routing as a matching process. We have an incoming request. We have a set of available endpoint. For example, here I have two endpoints. One of is get all and another is get all task. Okay, and the ASP.NET Core needs to find the endpoint whose route and HTTP method match the incoming request. So routing is basically help us answering this question. Where should this request go? Now, let's look at this line here. Route, API, and controller. This is an attribute routing definition. It's so important. We are telling ASP.NET Core that the route for this controller start with API. I told you in the previous episode. And then we have here controller. But what exactly is controller? It's so important. Controller is a route token. Don't forget, it's a route token. ASP.NET Core can use the controller names to replace this token here. Here, replace with here, come here. Okay, so tasks controller becomes task, and therefore API here, the API slash controller become API slash task, because the controller return the name of controller. The name of our controller is task controller, and we remove this part and we return this part, task, and the route becomes something like this: get API and task. So the base route for our controller is API task, can potentially match our task controller. And notice that I said potentially. That's important. Matching the controller's route is only part of those processes, and ASP.NET Core still needs to determine which action should handle this request. For example, HttpGet or HTTP post, HTTP delete, or HTTP put. And that's where our action level route and HTTP method come into play. Now, let's look at our action here. HttpGet. It's so important. The question is, what does the HttpGet do? It's so important. The HttpGet attribute tells ASP.NET Core, hey, that this action, I mean get all tasks, handle get request. So when we need get API task, the URL match our controller route, and the HTTP method match HttpGet. That's how ASP.NET Core know this action is a valid match. And remember, routing doesn't look at the URL alone. The HTTP method is also part of the matching process. For example, here we have get API task, and for example, here something like this. For example, HTTP post. Okay, and here I want to choose HTTP post, and it's becomes something like that. Post API task. Both of them have the same URL, but they can handle by completely different action. Now, let's make this a little more interesting. For example, here I have a list of tasks, and I want to create another action. Okay, we have this endpoint, get API task. But in real task management API, we also want to retrieve a specific task. For example, here I want to get a specific task. For example, something like this: get API tasks. And for example, task number 25. It's so important. How can we create that? We can define another action. For example, something like this. Here I say the access modifier is public, and I choose iAction result and choose something like this. Okay. Now close that, and here. And the HTTP method is something like this: HttpGet. It's so important, but I have to make a little some changes. It's so important. Now we have something new inside our route. Here we have HttpGet, but here we have HttpGet ID. Okay. This is called a route parameter. The idea is that part of the URL contains a value that we want to capture and pass to our action. For example, if I run the program, you will see the result. It's so important. Let me run that. Okay, we are waiting for the Swagger. Let me bring it here. Sorry. Here I have task management. It has post, get, and get API task ID. If I run that, it say, hey, for example, 25. It will return the special task ID is 25. Name is create API get, and the owner is Hossein. It's the value, for example, here was 25. So if the client requests here, for example, 25, let me come here, and the URL will be something like this: get API tasks and 25. And ASP.NET Core can bind that value, I mean 25 parameter to bind that value to the ID parameter of our action here, I mean. Okay, so conceptually we have API tasks, something like this: API tasks ID, and the actual request is something like this: get API task 25. The idea is the template. The 25 is the actual value supplied by the client. It is extremely common in web API. For example, get API task 25 might mean get task number 10. And get API task 25 might mean a get task number 25. The route stays the same. Only the value of the route parameter changes. Let's add some other HTTP method like HTTP post, HTTP put, and HTTP delete. We can have, for example, HTTP post. Here I have created some HTTP post here. Let me remove that and create it from begin. For example, here I say HTTP post and say public and add action result and say something like this. Now, here I'm getting a task model from the body, but now I don't want to go deeper and explain a little about the task model and from body. Here, this action represent our create operation. For example, when we want to create a task, we have to send a task model. What is a task model? Here I've created a class is task model. It get ID, name, and owner. If I run the program, you will see what is task model. If I take here and say, hey, sorry, HTTP API task, it will take us ID, name, and owner. For example, if I say try it out, you can say, for example, the ID is 2, the name is something like this, Hossein. For example, create post API, and the owner is Hossein. Something like this, and press the execute. For example, you will see something like this. Now I close that and come to my controller. Now, another one. Here the route is something like this: post API task. Okay, but another one is HTTP put. For example, I come here for saving the time. I just paste that here, something like this. For example, HTTP put and do something like this. Very basic. Say access modifier public, I action result, update. For example, we call it update task, and it will represent an update operation for a specific task. For example, the route is something like this. Let me come here and say put API task, and the ID is 10. So now our controller could expose endpoint like this. For example, get API task, it will get all of the existing tasks. Get API task ID 25, it will get a specific task. The next one is HTTP post. It will create a new task, and put API task 10. It will update the existing existing task, for example. And the last one, we can create something like this. For example, let me copy that and paste here. For example, the last one is HTTP delete. It will delete the specific task from our list or our dictionary. It's not so important. Notice something interesting. The URL and the HTTP method work together. For example, these two requests have exactly the same URL here. Sorry, a post API task, get API task, these two. Get API task, but they use different HTTP method. This one use HTTP get and this one use HTTP post. One is get and the other is post. They can therefore be handled by different action. This is one of the fundamental idea behind the HTTP APIs. For now, we are not gonna to implement the actual create, update, delete logic, create and for example install entity framework, create SQL, MySQL or PostgreSQL database. We are only interested in understanding how these requests are mapped to our action. We will implement the real cloud operation in the next part. Now, I want to point out something that beginners often misunderstand. Let's say I'll rename this method, for example, get all tasks to something like this. Whatever you want. Something like this. And run the project. And if I come here, and you will see a get API task, and I rename that, but nothing bad happened. You will get all of the tasks. The road doesn't suddenly become different. If I still have HttpGet, I mean here, it's so important. This action is still configured to handle the GET request. The name of the C# method is not what defines the HTTP route. So, for example, this name, whatever you want, for example, get all or get the task call, do not automatically create different URL. The URL is get API task is here. API, the name of controller is task controller and is say API task. The routing behavior comes from the route attribute, I mean here, and the HTTP method, I mean here. Of course, in a real project, we should use meaningful method names, but that's for readability and maintainability. It's not what determines the URL. An important example, for example, to here I have two actions with the same route. For example, here the name of action is different. Get all tasks, whatever you want. But the HTTP method are both have HTTP get. Now, let's look at the mistake that can cause problem. For example, imagine I write, for example, this HTTP get and HTTP get. Both actions are configured for the same HTTP method, HTTP get, and both have the same route. Their name is get API task, and here it is get API task. Now, suppose the client send get API task. Which action should ASP.NET Core execute? Get all tasks or whatever you want. If I run the program, you will see the output. Here, the output is we fail to load API definition. There is no meaningful routing information that tells ASP.NET Core which one we want. We shouldn't expect the ASP.NET Core to look at the, for example, method names or decide, for example, hey, I get API test, I want to choose whatever you want, or get all tests. It cannot decide based on the action name or method name. The correct approach is to define routes that make the endpoint distinguishable. For example, here, HTTP get and HTTP get ID, these two, for example. Okay, now, the two actions have different route parameter. This one is get API task and this one is get API task ID. One match get API task and the other match get API task, for example, 25. So now the routing system has enough information to distinguish between them. Now it's time to create a very useful real example. Let's do that. let's look at one more example. For example, imagine we have these three actions. Get all tasks, it's the HTTP method HttpGet. The second one is get task by ID, HttpGet with ID. And the third one is create task, is HTTP post. Now, let's send three different questions. For example, the first request is get something like this. For example, say, hey, let me comment that. For example, get API tasks. The first request is get API task. The route matches the controller because the task is equal to this, and the ASP.NET Core choose task controller. There is no additional route segment, and the HTTP method is HttpGet. So ASP.NET Core select get all tasks. Okay. The second example is, for example, when we have something like this. Okay, get API task 25. The time we have an additional, this time we have an additional route segment that match ID. For example, 25 match this one. For example, this ID. Okay, so the HTTP method is also get because it's get and it get a special ID, and the value of ID is, for example, 25. So now, the third request, the ASP.NET Core will choose get task by ID. And the last one is something like this. Post, the HTTP method post API tasks. Okay. It will come to the pipeline. Okay. And the URL match the controller route. But this time the HTTP method is not get, it's post. So the get action are not the appropriate match. The action with HTTP post here, don't forget, the HTTP methods become the matching action. So ASP.NET Core select create task. This is the basic mental model I want you to remember. The request contain information. For example, get API task ID, get API task, post API task. This request contains information, and the endpoint contains routing metadata. ASP.NET Core compares them and find the appropriate endpoint. Now, let's step back and look at the bigger picture. When a client sends an HTTP request, for example, something like this, to our API, something conceptually like this happened. The request event an ASP.NET Core application here. The routing system examines the request and the endpoint that are available. It looks at the things such as the URL pattern and the HTTP method. If an endpoint match the request, ASP.NET Core select the endpoint. If it's control action, the framework then prepare the value that the action needs, including things such as a route parameter and request data. This is where concepts such as the model binding become important. Then the action is executed. I mean here. Request, routing, endpoint selection, model binding, and other processing. Action execution here, okay, and the response. We are gonna to explore several of these stages in much more details as we continue building this project. So let's summarize what we learned in this episode. First, a controller, don't forget, is a class that group related API action together. For example, task controller contains some existing action like get all tasks, get task by ID, create tasks, update tasks, and also delete tasks. In our project, I told you, for example, task controller contains an action related to the task. And second, routing is the mechanism that helps ASP.NET Core, for example, match an incoming request and an endpoint to an endpoint. Our controller has a route such as, for example, something like this. I told you, API controllers. Because our controller is called task controller, this one controller becomes task, and we remove this section and the task just remain. So our base route becomes something like this, API task. Then our action can add more information to the route. For example, here I told you it becomes something like this, API task ID. Or we can do something like this: get API task 25. For example, the ID is 25. We also learn that the HTTP method matters. Get, post, put, and delete are not just a label. They are part of information in ASP.NET Core can use when determine which endpoint should handle a request. So get API task, we can go to this action. For example, if it comes something like this, API task 25, ASP.NET Core will choose this action. Don't think of HttpGet, HttpPost, and root as a random attribute that you just have to memorize. Think of them as a metadata that describe how HTTP requests can reach an endpoint. Once you understand that, controllers and routing become much easier to reason about. But don't forget, at this point, our API knows how to receive different kind of requests, and route them to the appropriate action. But there is still a big problem. Our action don't actually do anything useful yet. For example, our create action doesn't really create a task. Our update action doesn't update anything. And our delete action doesn't delete here. We are just create some basic example. We are just returning here, okay, created that action, and we are just getting some basic. So in the next episode, we are gonna to change that, and we are gonna to start implementing CRUD operation. I mean, we are gonna to get all of the tasks. We are gonna to create new tasks, update existing tasks, or delete the task. Okay, don't forget. And I push the existing code to the repository on the GitHub. Don't forget to fork that and use it. And you also create some endpoint and create some new requests and see how ASP.NET Core will choose the existing action. Don't forget to like and subscribe the channel. I will see you in the next episode. Goodbye.